On a sunny September afternoon in LA, the camera crew of a news helicopter captured this unbelievable footage of a JetBlue Airbus A320. Apparently, its nosewheel seemed to be rotated 90 degrees sideways. Let's find out what happened here and how the following emergency landing went. Welcome to Airspace. On September 21st, 2005, JetBlue Flight 292 departed Burbank, California for its flight across the US to New York. Just after departure, the 141 passengers were settling in nicely for their 5-hour and 20-minute flight. On the flight deck, however, the two pilots noticed quickly that their flight might already be in trouble. Just after liftoff, after they had retracted their landing gear, a warning appeared that read "Landing gear, shock absorber fault." This warning alone is usually not the end of the world. Most of the times, it signifies that an internal dampening part of a landing gear strut has failed, and therefore the landing will feel rougher upon touchdown. The first officer kept flying the aircraft along its intended flight path while the captain ran the checklist. In an attempt to fix the problem, the pilots agreed to lower and raise the landing gear again, hoping that the fault would resolve itself in the process. However, after they had lowered the landing gear, another fault appeared, this time reading "nosewheel steering fault." From his training and from the manuals, the captain recalled that this specific combination of faults spelled nothing good for his flight. In fact, this combination could mean that the nosewheel of the A320 somehow became locked in the 90 degrees off-center position, completely sideways, if you will. The flight crew then contacted maintenance control to obtain some advice, but it seemed that no approved procedure existed to rectify the issue. To confirm their suspicions, the pilots decided to do a flyby of the tower at Long Beach. And indeed, the tower there confirmed that the nosewheel appeared to be in the 90 degrees cocked position. In the meantime, attentive local news outlets had learned of the situation and sent news helicopters in the vicinity of the JetBlue A320. Passengers were therefore able to see live footage of their unfortunate situation, since JetBlue had an in-flight entertainment system that allowed passengers to watch live TV. Quite unusual, I must say. Later, the flight attendants deactivated that system in order to not frighten the passengers further. The two pilots accepted their situation and began preparing the aircraft for the upcoming emergency landing. Since the plane had been fueled for a rather long flight, it was quite heavy. Therefore, the flight crew decided to burn off some fuel close to LA in order to become as light as possible for the landing. On one hand, this would reduce stress on the landing gear on rollout. On the other hand, it allowed for an approach to be flown at slower speed, which would further reduce the negative effects of the jammed nosewheel. The cabin crew even reseated passengers to seat rows further back in the aircraft to reduce weight on the nosewheel strut for the upcoming landing. After all abnormal checklists were completed, the pilots requested to land in LAX, where a long runway and modern emergency equipment was available. They were given clearance to do so and commenced their approach. They were closely monitored by more than one news helicopter, showing once again the nosewheel in its 90 degrees offset position. The plane finally touched down at 6:18 in the evening. You can see from the footage how the captain holds the nosewheel up for as long as possible. Just a little bit, not too high in order to not slam the nosewheel into the runway and cause further damage once the lift is bled off. Also, the crew did not use the reverse thrust or the ground spoilers on top of the wings in order to not create any pitching moments that would disturb the smooth nosewheel touchdown. Additionally, the pilots shut the engines down as soon as the nosewheel touched the ground to avoid the ingestion of debris, just as the checklist dictates. Every time the aircraft passed over a stripe on the runway, the disintegrating nosewheel hub sent sparks and flames rearwards. Quite a frightening display. Still, the pilots managed to stop the aircraft on the runway, all but perfectly on the center line. Emergency services quickly responded, but were able to confirm that after stopping, there was no fire. Therefore, no evacuation was initiated and passengers were able to leave the aircraft using normal stairs. They were bussed to the terminal and now had quite a story to tell. The same goes for the two pilots. After the incident, the National Transportation Safety Board closely inspected the nosewheel to determine what had caused it to rotate in such a strange fashion. The rest of the aircraft had remained intact. Upon closer inspection of the nose gear, the investigators discovered that 2 of the 4 anti-rotation locks had failed. These locks are intended to maintain the proper relationship between the shock absorber and the nose gear strut assembly. But why did they fail, and why had the nosewheel not centered after being lowered? Hydraulic power had been available after all. To answer these questions, the team worked closely with Airbus and Messier Dauti, the manufacturer of the A320's landing gear. What Airbus explained about the A320's landing gear operation surprised me. I've never heard of that despite having flown full-time on the A320 for 5 years. Apparently, to check whether the nosewheel steering will work on the ground, the braking and steering control unit performs 5 checks after the landing gear is lowered. The first 4 are completed rather quickly, but the 5th is continuously performed until the main gear touches the ground. It consists of constant movement of the nosewheel. During this 5th test, the nosewheel is rotated to the left by 2.5 degrees, returned to center, then 2.5 degrees to the right, back to center, and so on. Airbus explained that on average, 57 of these test cycles happen between the lowering of the landing gear and touchdown on every single flight. This frequently reoccurring motion took its toll on the anti-rotation lugs, which eventually fractured due to metal fatigue. Without those, the nosewheel was able to rotate freely in the nosewheel bay up to about 20 degrees and even further to 90 degrees when it was extended. But one question remains: why was the braking and steering control unit not able to center the nosewheel? Hydraulic power had been available for that, after all. To answer this, let's look at the logic of the centering mechanism of the braking and steering control unit. 1 second after the unit receives confirmation that the nose gear is down and locked, it determines the position of the wheel assembly. If it detects that the assembly is not centered, it will attempt to return it to this position hydraulically. A command is sent to the steering servos, and 0.5 seconds later, the unit monitors if the wheel assembly actually moves as commanded. If it does not, the nosewheel steering function is determined as failed and a fault message is displayed to the pilots. However, in this case, the steering would have worked perfectly well. As it turns out, Airbus made a rather strange design mistake when the nosewheel steering system was designed. You see, the landing gear operation is one of the most taxing tasks to do for the hydraulic system. The lowering and retracting of the heavy struts requires thick actuators that use a lot of hydraulic fluid. In order to not overstress the system, some hydraulic users are temporarily disabled with automatic priority valves during landing gear operation, such as, you guessed it, the nosewheel steering. In the case of JetBlue 292, the nose landing gear locked in place first, while the 2 mighty main gear struts were still in transit. The actuation jacks of these 2 are probably the most demanding users of hydraulic power in the entire aircraft, so the priority valve to the nosewheel steering was shut at that time to route full hydraulic power to these main landing gear actuation jacks. But just at that time, the braking and steering control unit detected that the nosewheel was already down, but in an offset position. It then tried to hydraulically center the nosewheels, but the nosewheels didn't move since almost all hydraulic power was routed to the main gear actuators. The braking and steering control unit then falsely assumed that the nosewheel was jammed, since it didn't move, and issued a nosewheel steering fault to the pilots. So in the end, this incident would have been preventable with a better design, or a means to reset the braking and steering control unit in flight, so that it might try to recenter the nosewheels once hydraulic power is available again. This incident was quite spectacular, and most people probably thought it was the first of its kind, but it was actually at least the 7th occurrence of an A320 landing with a nosewheel assembly rotated completely out of place. Airbus proved that some of the incidents were due to faulty maintenance, but also conceded that their design of the nosewheel steering and its associated tests were not optimal. The braking and steering control unit logic was updated so that the steering tests now occurred about 7 times less frequently, and the means for pilots to reset the unit in flight was provided. And as a last measure, the landing gear strut design itself was improved and made more sturdy. It should now be much less prone to fatigue cracking. The modification was made mandatory, and all A320s today should have it. However, during my research on JetBlue 292, I found a very recent case of a very similar occurrence. On March 6, 2021, a Batik Air A320 also had to land with a nosewheel that was completely rotated sideways. It landed safely in Jakarta, Indonesia. The reasons behind this failure are not yet known, so it might be possible that Airbus's corrective actions were not enough, or maybe this was a case of bad maintenance or something else entirely. I guess we will have to wait for the final report on that. And that was the story of the interesting landing of JetBlue 292. If you liked the video, please leave a like and consider subscribing. If you'd like to support this channel, click the Patreon logo in the bottom left corner. Your small donations help me grow this channel greatly. That said, thank you, and see you all in the next one.